Okay, so there was a lot happening this week and next week. Next weekend, of course, is your 4-day weekend. You get like a little mini vacation starting with Halloween. But I didn't want to stand up here and just rattle all this off because it's going to be real easy to miss something. So I thought I'll just go ahead and visually show you what's happening on a calendar. Okay, so we are the 20th right now. So we're going to go ahead and start our next lesson where we're proving trigonometric identities. So tomorrow I will not be seeing you folks. In fact, I won't even see you until Thursday because tomorrow is the PSAT and I'm going to be gone all day on Wednesday because I'm going to be at the home office for professional development. So tomorrow you are going to periods 5 through 8. Remember that schedule is on the website. So if you're testing the PSAT, good luck. Make sure to bring your charged Chromebook. If you're not testing the PSAT, it's a late start day for you. Okay, so that's good. All right. On Wednesday, while I'm gone, you picked up today this homework assignment. It says Unit 6, Homework 2, the simplifying trig expressions. This is what you're going to work on that class period with Mr. Brooks. Okay, so absolutely work together. In fact, I encourage it. Please take the opportunity, work together. No cell phones, nothing like that. I know you folks are going to do a great job. Okay. And then when we come back on Thursday, we'll talk about the homework. We'll continue proving trig identities Thursday into Friday. We'll have SEL. Now, one more thing about this week, because the PSAT is tomorrow morning, there won't be any morning tutorials. There will still be afternoon tutorials on Tuesday. Okay. If I were in my room, that wouldn't be a problem, but they're moving me up to the 3rd floor, so none tomorrow morning. And because I'm gone Wednesday, there won't be any afternoon tutorials that day either. So I do apologize for that. Remember last week we took the basic trig identities quiz. Because this week is so unusual with the PSAT and my being gone, you're going to have until the 27th that morning to go ahead and retake it. So through this week, the start of next week. Okay, so you got plenty of time. Don't worry about that. On Monday after the weekend, we're going to have ourselves a little trig expressions group activity. Then on Tuesday the 28th, we're going to have a simplifying trig expressions quiz. I know I mentioned that that was originally going to be on this Friday the 24th, but what's happening on Friday the 24th? It's pep rally. We got homecoming. We also have SEL. So I'm figuring a lot of people probably getting closer in the afternoon are going to be gone. So I think this is going to work out better for you folks. We get another whole week of practice with a group activity practice before you even take the quiz. So I'm thinking that'll help out a lot of folks by the time we get there. We'll go ahead and start looking at double angle identities next Tuesday, Wednesday, and then next Thursday, that is the 30th, that's going to be your first exam. Okay, so kind of think about it, the last quiz that we took, the basic trig identities, with this quiz that we're taking on the 28th where we're simplifying trig expressions. Just kind of think about those two merged together, and that'll be basically your exam. Okay. And just like always, I'll let you use a 3x5 note card. I'll pass those out this Friday. Okay. Like I said, that was a lot of information, but are there any questions about that? Okay, good to go. Okay, fantastic. Well, go ahead and take a look at this document right here. Guidelines to verifying trig identities. So this is just a more comprehensive version of what we've been talking about basically the last week and a half. Okay. Now, we're not dealing with expressions in this lesson. We're dealing with equations, which means we're going to have an equality symbol. So you're going to choose one side of the equation to work with, whatever you think is the more difficult. And I'll explain why when we get there. But we've got a lot of strategies that can help us. Of course, the top one is rewriting everything in terms of sine and cosine. You've got all these algebraic operations you can perform. In fact, B, factoring, that's what we just started looking at the end of last week. Look for trigonometric things that you can do. If you have a square, you could use a Pythagorean identity. Remember, when you multiply reciprocals, the product is always 1. That can come in very useful. Now, keep looking at the answer. That's your goal, making sure you're on the right path. What's important, don't quit. If you start running into problems or you think it's getting a little too complicated, go back to the drawing board, try to think of another idea. Remember, there's going to be multiple ways to simplify these problems. And then, of course, number 7, because we're proving identities that are given to us, we're going to go ahead and put QED at the end of them. In mathematics, we like to, write everything in as simple a version as possible so that anybody, especially if somebody doesn't have a background in mathematics, can read what we've done and understand what it is that we're trying to say. So we're going to go ahead and put QED. For us, that means quite enough done. That'll signify to anybody looking at it, that's the end of the proof. Okay. Let's go ahead and look at an example. Now, this isn't trigonometric. This goes back to algebra. So you might remember solving these back at good old Algebra 2. This is a rational equation. Now, here's the thing. We are not solving this. We're not trying to find the value or values of x that make this true. We simply want to go ahead and show that this is a valid equation, that we would get a solution. Okay. Now, of the two sides, which side would you say is more complicated? Definitely the left. See, this is what that previous document was talking about. It's going to be so much easier to start with the more complicated side and rewrite it and condense it down to whatever's on the other instead of, say, taking 2 and trying to balloon it up into the left side. Does that make sense? Okay. Well, do you notice anything about these numerators right here? X squared is minus 1. They are the same, but what kind of binomials are they? Blank of blank. Difference of squares, yes. Okay, now remember, when you factor difference of squares, we get groups that are called conjugates. So x squared minus 1, that becomes x plus 1, x minus 1. Okay, divided by x minus 1. So remember, these are what we call conjugates in the numerator. The first terms are identical, but it's the second terms that are opposites. Basically, same terms, 1 plus, 1 minus. Okay. Now, minus, this one right here in the middle. We have another x squared minus 1, so I'm going to say x plus 1, x minus 1. And then this is over x plus 1 is equal to 2. Well, now that I've factored the numerators, do you notice anything I can do? Yeah, I can cancel out some groups. So over here, the x minus 1's cancel. Over here, the x plus 1's cancel. So I'm left with x plus 1. Now, when I subtract, I'm going to need to make sure to distribute that negative across the binomial. So this is going to be minus x. Subtracting a negative changes it to addition. And what happens here? How would the left simplify? What happens with my x's? Yeah, x minus x, those cancel. 1 plus 1, 2 does equal 2. See, that's what we're wanting to do here. We're wanting to choose one side of the equation, rewrite it, rework it, so that I get the other side. But we're just going to be doing that with trig expressions. Okay. All right, so questions? Put QED right here. Okay. Yeah. Is 2 a solution? Let's see, that would be... Actually, I don't know. I never solved this one. So let's see, that would be 4 minus 1 over... Okay, or that would be 2, 2... Okay, so that would be 4 minus 1, 3 over 1 minus 3 halves. Yeah, that is not going to give you 2. No, no, no. We just verified that it was a correct equation. Lexi, you're okay with that? Well, I just plugged in 2, and that doesn't equal 2. See, we're not solving the equation. We're just showing that one side will equal the other. They're comparable. That it's a valid equation. So I have no idea what value of x is going to make this true. I know for certain it's not 2. Okay. All right, so let's take a look at this right here. Okay, so we're going to prove each identity. Okay, so we're given these new identities, and we want to show that they're accurate. So number 1 says cosecant of theta times cosine squared of theta plus sine of theta equals cosecant of theta. Okay, So between the two sides, the left and the right, which side would you say is more complicated? Okay, so we're going to start with the left. Let me go ahead and highlight this right here. So that is the side that we're going to work on. See, when you're working these types of problems, you cannot work across the equation. Now, you can work both sides simultaneously and come meet in the middle, but that's as far as you can go. You cannot work across the equation. We got to choose one side. So somehow I've got to take cosecant of theta times cosine squared of theta plus sine, and I need to rewrite it as cosecant. Okay, so ideas. Can I do something algebraic? Do we notice an identity I could use? What do we think? Yes, servation. You want to make this sign cosecant? Okay. Did you want me to change anything else? You mean cosecant plus cosecant? Unfortunately, I can't do that because, see, that cosecant's connected to cosine squared. Now, if I had something like cosecant plus cosecant, yeah, that is absolutely two cosecants. The cosine squared's kind of throwing a wrench in there. Okay. So, James, what do you think? So you want me to change that to 1 over sine? Okay. So cosecant is 1 over sine of theta times cosine squared of theta plus sine of theta. Okay. Now what? Remember our goal. Somehow this has to end up as cosecant of theta. Go ahead and actually make this one fraction. Sure, we can do that. So I can go ahead and say cosine squared of theta over sine of theta plus sine of theta. Okay. All right. What you got, sir? Say again. Oh, I see. Oh, so okay. So you want to make this a fraction and common denominator. Okay. Now I see what you're saying. So let's multiply this by sine of theta over sine of theta. Okay, we can absolutely do that. So let's see. Is everybody to the point where I can go ahead and combine them, or should I show the next step? Everybody's okay? Does anybody want me to show the middle step? Okay. So I'm going to have cosine squared of theta plus sine times sine will give me sine squared of theta over that common denominator sine of theta. And we're right there if you see it. What does cosine squared plus sine squared equal? 1. And 1 over sine is cosecant. QED. See, that's all we have to do. It's exactly what we were doing over the last week. It's just that now we know where we have to get to. And remember, is that going to be the only way to work this problem? No, there's going to be a lot of others. Okay. All right, well, let's try another one. Let's try number 2. So number 2 says sine squared of y over cosine of y equals secant of y minus cosine of y. Now, there are times where you could make an argument for using one side or the other. Okay. So in this one, you can actually do that. Okay. I could start from either the left or the right and should be able to get to the other side. So what would you like to start with? The left side or the right side? Left? Okay. So let's start with the fraction. So somehow I have to rewrite sine squared of y over cosine of y into secant minus cosine. Now, my one bit of advice when you're working these kind of problems, because you already know where you're headed, what your final expression needs to be, I would say that as you move through your steps, you start to see more and more of the other side take shape. Okay, like let me help you out with this one. Because I have a squared in the numerator, I can immediately use a Pythagorean identity, right? Okay. Would everybody agree that sine squared is 1 minus cosine squared? Does anybody want me to show over to the side how I got that? All I did was replace the numerator. Okay. But you'll notice we have to subtract two terms. What did I just introduce? I just brought in that negative. See, that's what I'm talking about. You want to start seeing parts of the other side coming in. Okay. So now what? Okay. So we've got one fraction. Why don't I take these two numerators? We'll just break it apart. So 1 over cosine of y minus cosine squared of y over cosine of y. Well, let's see. What's 1 over cosine? There's your secant minus, and now we can cancel out a pair of cosines. And see, it gives me exactly what the other side is. That's what we're doing here. Okay, so Q, B, D. So let me ask you a question real fast. Last week, we were just dealing with an expression. So you had no idea, besides the fact that I told you it was going to be a single term. Do you think it's easier or more difficult that you know what your final expression should be? Think it's easier? Fantastic. I love to hear it. Okay. Well, let's try another one. Number 3. Cosine squared of alpha equals sine squared alpha times cosecant squared alpha minus sine squared alpha. What do you think, the left side or the right side? I would definitely start with the right. There we go. It's going to be so much easier to take a larger expression and rewrite it, use algebra, condense it down to a smaller expression term than to go the other way. Okay, so ideas. Somehow I got to end up with cosine squared. Cosecant in terms of sine. Okay. So that would be sine squared of alpha times 1 over sine squared of alpha minus sine squared of alpha. What does that allow me to do? There we go. See, those are going to cancel out, so there's 1. And it also makes sense here because sine and cosecant, what's the relationship? Reciprocals. When you multiply reciprocals, you always get 1. Okay? So I've got 1 minus sine squared of alpha. So I'm hoping we're starting to get more familiar, especially with these Pythagorean identities. What does 1 minus sine squared equal? That's cosine squared. There you go. That's it. Q, E, D. You want to get from one side to the other. Okay. Now, we've talked about it. I haven't shown you on any of these. Let me go ahead and show you another way, because there's always going to be multiple ways to work these problems. With this binomial, did anybody notice that sine squared was a greatest common factor? Okay. Let's go ahead and divide that out. So sine squared of alpha, that would leave me cosecant squared of alpha minus 1. Can anybody help me? What is cosecant squared minus 1 equal? Oh, you have your match? It's cotangent squared, yes. So this is going to be sine squared of alpha times cotangent squared of alpha. Well, why don't I go ahead and use a quotient identity now? So sine squared of alpha times cosine squared of alpha over sine squared of alpha. The sine squareds cancel. See, I still get cosine squared. That's it. You got your starting line. You know where the finish line is now. You just have to connect the two. Okay. Is anybody having a hard time? Anybody lost? Okay. So I know what you're thinking. Mr. West, I got this. I'm ready. Okay. Try number 4. Okay. So I'm already thinking I know what your answer is going to be, but what do you think? Left or right? I'll definitely start with the left. Okay, so I'm going to go ahead and pitch you a couple of ideas before I give you a few moments to try this one. Okay? So the first thing, you could distribute tangent across those parentheses. Okay, that's one way you can start the problem. Okay, you could also rewrite everything in terms of sine and cosine. Okay, or you could leave that tangent alone for right now. You could focus on just the parentheses, get a common denominator, and combine those into a single fraction. So right there's already 3 different ways to start. Okay, so let me give you 2 minutes. Okay, and let's see how we can rewrite this. That's cosine. You have to use your bathroom, guys. I'm going to see if I can talk to Barry again and get that working, because it was working last year. Now it's not working again. If I can get that fixed, that'd be great. 30 seconds. Okay, so you may not be completely done, and that's okay. Okay, at least I gave you a head start. So I could distribute the tangent, turn everything into sine or cosine, or I could focus on the parentheses. What would you folks like me to do? You want me to distribute? Okay, let's distribute. Okay, so tangent times secant over tangent, those cancel. So now here's secant of x minus. So what's going to happen if I multiply tangent by that second fraction? What am I going to get? Tangent squared. So it's going to be tangent squared over secant of x. Okay. All right. Now what? Common denominator? Okay. So let's say I go ahead and put this over 1. So the common denominator would be secant. Okay. Well, that means I only have to multiply this one. So I'm going to go ahead and say secant of x over secant of x. Okay. So if I multiply those, this whole thing is going to be over secant of x, but secant times secant is a secant squared minus the tangent squared. Is everybody okay how I went from my first step to that one? Okay. Well, somebody help me out. What's a secant squared minus tangent squared? It's 1. And what's 1 over secant? That's cosine. See, that's exactly what we should be getting. Q, E, D. just like that. You just have to connect the two. Did anybody want to see this by rewriting everything in sine and cosine? Okay. Spoiler alert, what's going to happen? Well, true. I mean, you got two different methods, but you're still going to end up at cosine, right? Okay. So let's see here. Tangent, so that is sine over cosine times, so secant, that's 1 over, oh, interesting, cosine of x, all over, tangent is another sine over cosine, minus, then we have a sine over cosine, all over 1 over cosine of x. Okay. All right. Now what? Well, since I turned everything into sine and cosine, I would probably go ahead and simplify those fractions by multiplying by their reciprocals. We're dividing by a fraction. Okay. So let's see here. If I take this and multiply up, I'm going to have sine over cosine. Okay. So that's just going to give me 1 over sine of x. Okay. Does anybody want me to show how multiplying by the reciprocal on that first part gives me that? Okay. So let's say I have over here 1 over cosine, and I'm dividing that by sine over cosine. Well, I'm going to multiply through. So I've got that numerator, 1 over cosine. This denominator flips. So now it's cosine over sine. And see, those cosines cancel. So that's where I got the 1 over sine. Okay. So this next one, if I multiply by cosine, this is just going to be minus sine of x. Okay. Everybody's okay so far? Now what? I can continue to work inside the parentheses, or I can distribute. Oliver? Continue inside? So what would you like me to do? Okay. So let's go ahead. Why don't we put this sine of x over 1? So the common denominator would be sine. Okay. So I've still got this sine of x over cosine of x outside times. Now, if I multiply these together, I'm going to end up with sine squared over sine. So I'm going to have 1 minus sine squared of x over sine of x. That's a Pythagorean identity. 1 minus sine squared is cosine squared. So I'm going to have sine of x over cosine of x times cosine squared over sine. And let's see here. I can cancel out a pair of sines. I can cancel out a pair of cosines. And what am I left with? Cosine. So it definitely had several more steps, but I still was able to get to the right answer. Okay. All right. Any questions on what we're doing? Anybody lost? Okay. All right. Well, let's try number 5. Okay. All right. Number 5, cotangent squared of theta equals cosecant squared theta minus cosecant squared times sine squared. This is another one of those. Well, first off, I think everybody's going to choose the right side. Okay. But it's another one of those problems where if you notice it, you're right there. What could I be referring to? Okay. So on the right side, we've got this binomial with cosecant squared being a GCF, right? Okay. So if I were to go ahead and factor that out, cosecant squared of theta, that would be 1 minus what? Sine squared. Okay. And I was just thinking, James, is that what you wanted me to do? Or were you talking about something else? Is that what you wanted me to do? Or I was just thinking, is that what he said? Okay. Did you want me to change it? Okay. All right. Well, now what? Okay. So I've got cosecant squared times 1 minus sine squared is a cosine squared. Okay. Well, let's go ahead and use a reciprocal identity now. Cosecant squared is 1 over sine squared, right? Times cosine squared of theta. Well, cosine squared of theta over sine squared of theta, that's cotangent squared of theta. Now, thinking about what you just said, I think you were referring to something else. First off, Lexi, yes. Uh-huh. Just take a look. If I were to redistribute, because see, I still ended up with a binomial expression, right? So cosecant squared times 1, there's your cosecant squared. Then we've got the minus cosecant squared times sine squared. There's that other product. So I just divided it out from both terms. So I think this is what James was saying a moment ago. If you take a look, remember, what are cosecant and sine to each other? They're reciprocals. So what's cosecant squared times sine squared? So cosecant squared of theta minus 1, that's cotangent squared of theta. Is that what you were saying? Yep. And I went ahead and factored out a GCF, but it works. It works both ways. Yes, okay. All right. How are we doing? Okay. All right. So we're out of here at 55. Okay. So we got about 5 minutes left. What I'd like for you to do, try number 6. Okay. So this time you've got basically 2 days to do it because I won't see you again until Thursday. Okay. So please, even if you're not able to get it completed all the way to the end, at least try it. Okay. Remember, practice is what's going to get you better. Okay. All right. We are done.